Welcome back, tubers. So a bit of an update on the grid tie inverter. However, quick recap, I'm using a grid tie inverter with a limiter. A normal grid tie inverter will just put out whatever DC power and it will just turn it into AC. However, the one I'm using is a model that has the limiter on it, and what the limiter does is it uses a CT clamp, which is one of these, and that is wrapped around one of the cables and the mains that are coming into the house. So what it does is it monitors whatever loads are on in the house, and the grid tie inverter only puts out as much as the loads are using, which is fantastic when you've got it connected to batteries. It's pointless obviously if you've got it connected to solar panels because you want it to turn as much DC solar into AC. However, when you've got batteries, you only want it to turn the minimum into AC so that you're not just draining your batteries for no reason, or just putting it out to the grid, and you're not going to get much for that. So what I'm doing is I've been using the grid tie inverter, and it's got the limiter. What I've done in probably a few videos ago was I extended the CT clamp because the garage to the house is about 5 meters apart. However, the cable length is about 20 meters. So what I tried to do was I tried to extend this cable pretty much cutting it in half and extending it by 20 meters so that I could leave the grid tie inverter here out in the garage, but have the CT clamp and the readings around the main fuse box inside the house. Now that's worked fairly well, however it's not perfect, and it's far from perfect, and the reason for that is just a long cable run. And if you watch some of my earlier videos, you'll soon notice that the power, while this is reading say 200 watts, the house is using 250 watts, so we're buying 50 watts from the grid, and at times we're buying 100 watts from the grid. So overnight the key purpose is to use the Powerwall, and the best thing to do is use the Powerwall at night, or especially in the early hours of the night where the load is really low when everyone's asleep, and it's perfect for the perfect conditions for the Powerwall. So what I'll do is I'll just show you what I've done. These are the changes that have kind of come up and the reasons I've done them. So if we have a look at the top of the inverter, this is the connection for the CT clamp that I extended 20 meters. I had it running across just the concrete outside. That was an absolute pain. It looked messy and it wasn't an ongoing long-term solution, but it was a good solution to test. Now, however, as I previously said, I'm not too happy with it not being exact and missing out on still having to buy grid power when we really didn't need to, because we do have enough batteries here. So what I decided to do was bite the bullet and buy the external limiter. The advantage of the external limiter is that you can have between the inverter and the limiter, the external limiter itself, you can have a cable run of pretty much the same CT clamp cable of 30 meters. Now I only need 20 meters, so what I decided to do was I purchased the external grid tie external limiter. I asked them for a 20 meter cable. It pretty much came with a cable with two of these ends on it, and I ran the cable outside underground. I'll show you what it looks like outside underground, then I'll show you what it looks like inside the house and where I've mounted it. So tubers, that is where the cables come out of. So that's the hole I made on the side of the garage, and then it needs to go under this concrete, so I managed to burrow through using a hose and a water blaster, and I managed to be able to get the hose under there, which is why it's popping out at the top there. And then obviously the next thing is that these three cables here, which this is the CT cable, and this one here is a Cat 5 or Cat 5e cable, and this is also Cat 5e cable. So the idea is to put also, since I'm running one cable, I might as well also run two more. So this one here is going to be gigabit network for the garage. When I'm working on different things, it's going to be handy to have network out in the garage rather than relying on Wi-Fi. The next cable is obviously the same type of cable, but I've terminated this next to the switchboard inside, and that way if I ever needed to run any relays or anything like that, or switching or monitoring or anything, I could use the 8 cables in here. So the next thing is really putting all this underground. So what I've done is that cable just goes in a big kind of it's just laid out all over the concrete there. So what I've done is I've dug this trench in here, and that white pipe there is what I need to run the cable in, and that cable needs to go all the way down here and then in down the bottom there, and that's where those other cables are coming out of. So eventually what is going to happen is that all that's going to be put underground, and it's going to be nice and tidy and neat, because in the last 3 or 4 months I've been running the CT cable just across the concrete, and it gets in the way and it's a complete pain. So now it's time to stick that underground, now that everything's kind of working. And so this is how it looks before we put things in the ground, and I thought I'd do it before and a bit of an after on this part of the video. So as we fly down, you'll see the solar panels on the top of the house and obviously the garage there. And now this is the window that is where the laundry is, where the main fuse board is. And what I've done is I've run the cable under the house and around through to the garage, and this is kind of how it looks. And you can kind of get a really good idea about how far away the garage is from the house. And remembering that the main reason I did all this is I really wanted the cables and the inverter and all the battery stuff in the garage rather than in the house. So this is how it's looking. It obviously looks a bit better with the dirt back in, and so I've put that in there. It's terminates here, and that's come up pretty tidy, which is alright. So I just need to I don't know, figure out what I want to do around that hole that goes into the concrete. But apart from that, obviously the cable goes under here, up and around. I've got a pile of dirt at the end there, mainly because the dirt just doesn't fit back in once you take it out. Like anything really, anything you unbox never seems to go back in again. So yeah, I have a bit of excess dirt, but that's okay, because it'll eventually sink down, and then I can just top it up. So yeah, that's how it's looking outside. Oops, I completely forgot to show what it actually looks like on the monitoring. So this is where you'll see the big difference. So what I've got here, this is back in January, and this is how it was. So for you guys that watched the video, you remember that it didn't really drop down below about 100. So this is kind of how it looked like over a couple of days. Now if I zoom into just this small section here, you'll see that it kind of sat around the 80 to, or 60 to 80, and all up and down throughout the night. So majority of the time, however, this is whenever the fridge turns on, by the way, it just seems to be an interesting load. But either way, you'll see that if I just zoom in on that small section, that this number here is 40 and it goes up to 80, and at times it'll go just over 100. So this is the problem that we're trying to solve. And so that's kind of what it used to look like. Now if I change it over to the weekly look, this is how it now looks. So you'll see this bottom bar here is much smaller. So it is quite an improvement. So if I zoom in that one more time, you'll now see that this is, I think, just the other night, last night. Now you'll now see that this is almost touching the very bottom, to the point that we're just picking up noise in the CT clamp. So if I zoom into this section here between 7 o'clock in the morning and some period at night, you'll see that even though it drops to below 0, it's actually about 1 or 2 watts that it's still using from the grid. It's very minor, but the monitoring is picking it up as 0 or just under 0. So if I enlarge that again, you'll still see that the fridge is doing some weird things to it. It's obviously much better, but overall it's about 20, about 10 to 20 on kind of average there, watts that it's using from the grid. However, we're getting to the point now that this up and down is becoming less and less accurate by using the CT clamp. So while it might say 20, what the smart meter on the house for the utility company is actually picking up could be very slightly different as well. So anything under about 30 watts, the CT clamp, you start to struggle picking it up nice and accurately. But either way, it's made such a big difference when we look over the period of last night to how much power we actually used over that period. If I just pull up that period just there, we only used, if we look at this number here, which is 0.02, we only used 200 watts of grid power over the whole period of that night. So that's really good. On the old system where I had the extended CT clamp, this was around a kilowatt hour. So we're saving quite a lot of power each night, which is what actually makes the unit pay itself off. So I thought I'd add that in there. I almost did the video without doing that. So if we come inside the laundry, this is what I've mounted on the wall. So what I'll do is I'll quickly run you through what it looks like, what it does, and its kind of overall functions. The cable that I ran outside comes up the bottom of the floor there, and up, and it comes into the top of the external limiter. So this is the CT clamp run that pretty much connects this to the inverter that's in the garage. What this pretty much does is it sits in between the CT clamp that's up on the fuse board and the inverter that's in the garage. So it's sitting in between, and it's doing pretty much nothing else apart from extending the signal. So if what I'll do is I'll quickly show you through this. So I've got power that comes through here, AC power, that rather than having a plug and terminating it as a plug, I've got it going into the connection box, or the AC connection box on the side here, that you probably can't see, but it's tucked away in there. So 240 volts comes into here, which was what powers this unit up. Now the other thing is that this bottom clamp, or this bottom cable here, is the CT clamp input, and this is the CT clamp output. So the CT clamp input runs down here, goes up the wall, all the way up behind all this, through the wall really, and out to here. Now this is in this mess behind here is around the main input cables, or the main AC cables into the house. Now this has also got a couple of other CT clamps that I've got for monitoring and other bits and pieces, so that's why it's quite full inside. However, the CT clamp for the external limiter is probably I think it's the top right hand side one. However, that's pretty easy to connect up and to get going. Now if any of you are playing with this unit, or just got this type of unit, as soon as you connect AC power onto it, and this is a bit of a tricky thing, is that you connect AC power, but it takes 2 minutes and 13 seconds to boot up before anything comes up on the LCD screen. I forgot what it says. I think it says welcome, but that kind of caught me out, because I was connecting it up to AC, turning the AC on, and nothing was really showing up, and it was a real pain, because I was thinking, well, what's going on? And it took me about 15 minutes until I actually left it turned on, walked away and came back, and the damn thing had started up. So I couldn't figure out why that was happening, but then I realized that it was taking such a long time to start up before it actually does anything, that it's quite easy to think that it was broken where it clearly isn't. So what you can also do on this is that you can see what the house is currently using. Now when the inverter is turned on in the garage, this number is pretty much as close to 0 as possible. So this is what the house is using right now, but when the inverter is turned on, this number here drops all the way down to as close to 0 as possible. So this is what we're using from the grid or the utility. And apart from that, because I don't have anything else connected into here, this is kind of acting in remote location, which is obviously you have the grid tie inverter in a completely different room to this unit here, which case all this can see is the utility power or the grid power, and all these other functions obviously aren't used, mainly because it hasn't got input going into here, so it can't read anything in here, which is fine, because that's not what we're using it for. We're only using it to pretty much extend the CT clamp. So that's how that's looking. It actually looks really good on the wall. It's as I said about the startup thing, now that it's on, and I know it takes 2 minutes to turn on, it doesn't really matter about the startup speed at all, because, well, let's face it, it's on 24/7 and it's on all the time, so it never gets turned off, in which case we don't have to wait for it. But that was a bit of a trick when I first got it going. Now I also see it's got signal A and signal B, so I do wonder if you can have two grid tie inverters connected to it. I think you can, because that might be handy later on. But so that's where the cables come up from, that I ran across the ground, or in the ground now, and the other two cables go up to the wall, and one terminates above all this, so that if I needed to connect to any relays and bits and pieces later on, I've got a cable that's already run underground, and that's made it really simple. So this is what the grid tie inverter looks like, the external limiter looks like on the wall. It's a pretty good unit. For 120 bucks, it's definitely worth it, and especially for my situation. However, if you had your batteries in this room and you had your the normal or the grid tie inverter that I've got in the garage, if I had that in here, then obviously I wouldn't need that. The only reason I've got that is because of the cable length. So so that's a bit of an update, guys. I hope you enjoyed the video. Subscribe if you haven't subscribed yet, and I'll see you on the next one. Thanks, guys.